1.4 are the different types of functions that exist and how you compute their rate of change. There are three types of functions that exist. They are either constant, which is in the form y equals b, y equals some number, y equals 2, and they are always horizontal lines. Or a function can be linear, which is in the form y equals ax plus b, where a is the slope. A constant function is also linear, but if the line is horizontal, it is best known as constant. If the line is sloped, it is known as linear. And the third kind of function we can have are nonlinear. You cannot write it in a linear form. You cannot write it as ax plus b, which also means the exponent on the variable has to be something other than 1, where the variable's exponent in this form is 1. So if it's nonlinear, it is something other than 1. And graphically, it is not a line. It is a curve of some sort or anything other than a line. Some new terminology are whether functions are considered discrete or continuous. A discrete function is simply a scatter plot of points. A continuous function is a plot with no breaks. The sketch can be drawn without lifting your pencil, like the parabola. I do not have to lift my pencil to draw it. When a function is linear, we say it has slope because it needs to be in the form y equals ax plus b, where a is your slope. So slope means your rate of change. Slope is rise over run, change in y's over change in x's. If you're changing your y's, it means you're finding the difference between your y coordinates. And if you're finding the change in your x's, it's the difference of your x coordinates. When a line has positive slope, we say it rises from left to right. We look at all graphs from left to right. So as we're going from left to right, it rises. When a function has a negative slope, it would fall from left to right. So as I'm going from left to right, it falls. Notice this is a positive sloped line, so it leans to the right. Our positive numbers are to the right. This is a negatively sloped line, so it leans to the left. Our negative numbers are to the left. If a function has zero slope, it is considered a horizontal line. Slope is also known as m, so slope would be 0. If a line has undefined slope, it is a vertical line. So if I pick any 2 points, my rise would be 1, my run would be 0, and that is undefined number because you cannot divide by 0. Where in this horizontal, my rise is 0 and my run is 1, so that comes out to be 0. All nonlinear functions do not have slope. Instead, we compute an average rate of change over a certain domain. It means we will pick any 2 x values and compute their y value, and then I will have 2 points that I can find the slope between. but it is always a curve when you are finding an average rate of change. Some examples of nonlinear functions are the square function. F of x equals x squared. So when you look at the function, the exponent is something other than 1. It is a curve. The cube function. F of x equals x cubed. The exponent is something other than 1. Again, there are curves to this function. Another example is a square root function. Now this one does not have an exponent on it, but you can only have slope in a linear function. So this is nonlinear because I am square rooting. The only operation I can do in a linear one is multiply and then add, not square root. Likewise, y absolute value. That is another operation. If you look at these graphically, the square root graph is also a curve. If you look at this graphically, it is not just one straight line, but two. Functions are also known as increasing or decreasing. If a function is increasing it from left to right, which means as my domain increases, my range increases. So if you look at this function going left to right, it is increasing. The part of the function that is decreasing means as your x's increase, so going left to right, your y's will decrease. So notice here, as I pick 2 points, my x's are increasing, but my y's are falling, decreasing. Something new may be interval notation. We usually have used parentheses and braces when we have interval notation. If something is less than or greater than, we use the parentheses. When you have the equal bar with it, you will use the braces. So the first example I have is x is greater than 3. So a couple things I want to point out. On any number line, furthest to the left will be negative infinity, because as I go more and more left, I get negative. So the best I can go is to negative infinity. Furthest to the right is always positive infinity. So this was x is greater than 3. So at 3, I will have a parenthesis opening to the right. That shows me all the values beyond 3. So in interval notation, I started at 3, and it is not included because there is no equal bar, and I went towards positive infinity. Next is x is less than 3. So if it's less than 3, my parenthesis will open to the left. Always go left to right. In this graph, furthest to the left is negative infinity, and I go to 3, both in parentheses, because there is no equal bar, and you can never reach infinity. Next expression, 3 is less than x, which is less than 8. So I have 3 and I have 8. 3 is a left parenthesis, 8 is a right parenthesis, and all my x values in between. So I started at 3 and I went to 8 in parentheses because there is no equal bar. Now these next 3 all have equals in them. So x is greater than or equal to 3. So it will be a right opening brace when we have the equal bar. But it opens to the right because it is everything bigger than 3, which falls to the right. So when I write my interval notation, I start at 3, and it is a brace because of the equal, and I end at positive infinity, but I can never reach infinity, so it is a parenthesis. x is less than or equal to 3. So equal means a brace, and they would be all the numbers to the left of 3. So I would have my brace opening left. Furthest to the left is negative infinity to 3. Negative infinity gets a parenthesis because you can never reach it. To 3 gets the brace because that is what I'm equal to. And then 3 is less than or equal to x, which is less than or equal to 8. So my x's are to the right of 3 and to the left of 8. So that will open left on 8. So it is 3 to 8, both in braces because I am equal at both those spots. So let's try to compute some of these things. First of all, it says find the slope of each. Well, we know slope is change in y's over change in x's. So I'm going to start with this point. And in this point, my y is negative 8. And my other point is 3. So change is difference. Negative 8 minus 3. Since I began with this point, I must start with this x value. So 12 minus 7. And this gives me a negative 11 over 4. Nope, 5. Negative 11 fifths. And it is rise over run. So I leave this as an improper fraction because it is not rise and run. It is rise over run. Okay, let's find the slope here. I'm going to start with this point, my y. 2 minus 3 over my x's. Negative 2 minus negative 2. That gives me negative 1 over 0, which is undefined slope. If you have a graph, pick any two lattice points. I chose these two. And I'm going to count my slope from the bottom point to the top. I rise 1, 2, rise 2, run negative 1. That gives me a negative 2 slope. Does my line lean to the left? And yes, it does. This says without calculating, will the slope be positive, negative, 0, or undefined? Well, I'm going to look here is my y. Okay, so first, my y is 3 to 5. That is a rise. Then my x from negative 2 to 1 is also a rise. Positive divide positive will be a positive slope line. And the next one, my y's. From negative 2 to negative 2 is no change, 0 change. Then my x's from 1 to 3 is an increase. 0 divided by a positive number will be 0. Did no calculations, just looked what happened to each number. Now it says find the slope of these functions. Well, these are all numeric descriptions because they are all equations. So f of x equals 5x. My slope is the number in front of x. So here my slope is 5. F of x equals 7. I have no x's. So this is like writing y equals 7 plus 0 x's. So my slope is 0. F of x equals 2 minus x. What's in front of x is a negative 1. So my slope is negative 1. What is the average rate of change? This tells me that I have a curve, and I'm going to have to pick 2 points on the curve and calculate the slope between those. So they want me to pick x is negative 1 and x is 4. So f of negative 1 is a negative 1 squared minus 2 times negative 1 plus 3. That is 1 plus 2 plus 3. That is 6. So I have the point negative 1 for x, 6 for y. Then they also wanted me to evaluate at 4. So f of 4. 4 squared minus 2 times 4 plus 3. That is 16 minus 8 plus 3. That is 8 plus 3. That is 11. So x value of 4, y value of 11. And since I now have 2 points, I can find their slope. So between these points, on average, what is happening? Well, my y's go from 6 to 11. Well, my x's go from negative 1 to 4. That gives me negative 5 divided negative 5, a slope of 1. So on average, between these 2 points, they're increasing, rising by 1 unit. These directions say, interpret the rate of change, evaluate f of 4, and then give that interpretation. So 3 things. Interpret the rate of change. That means I want a sentence about the rate of change. Well, if I'm going to interpret the rate of change, I have to, first of all, find it. So I'm going to pick 2 points. I'm going to pick this point here, which is 0, 200. And I'm going to pick this point right here, which is 1, 300. So my rise is up 100 over 1. So that is a 100 slope. But I am to interpret that. So the whirlpool bath increases with 100 gallons per hour. Maybe it would be better to say increases by 100 gallons per hour. Now someone else might say the whirlpool bath fills at 100 gallons per hour. Both are correct. All right, so here I have my work to show me what my rate of change is. I have my interpretation of my rate of change. Evaluate f of 4. So I have to write f of 4 equals, even if it's from a graph, if it says to evaluate f of 4, I need to see that. So f of 4 is right here. Looks like it is a y value of 600. F of 4 equals 600. Then interpret that. So after 4 hours, the bath has 600 gallons of water. Now I have everything I am looking for. Next it says state whether a function is constant, linear, or nonlinear. Then state continuous or discrete. All right, so when we see this numeric representation, 0, negative 1, 1, 3, 2, 7, 3, 4, 3, 11, 4, 15, we can say that this is linear. Because if I take the change in y's from negative 1 to 3 is 4. From 3 to 7 is 4. 7 to 11 is 4. 11 to 15 is 4. Over the change in x's are 1. So 4 over 1 gives me a slope of 4. So if there is a slope, it is linear. Now these would be just points to plot. So that would make it discrete because it is a scatter plot. I cannot plot points without lifting my pencil. Now here is a numeric representation. F of x equals the absolute value of 2x minus 3. Well, we learned earlier that absolute values are nonlinear functions. They make v's. But to draw the graph of a v, I do not have to pick up my pencil, so that makes it continuous. Again, I have a I have a symbolic representation. F of x equals negative 0.2x plus 0.4. Well, that is linear because it is of the form ax plus b. And since it is linear, to draw a line would be continuous when I have an equation. Next, f of x equals 2. Well, the best description would be constant because it is of the form y equals b. Y equals some number. And it is a horizontal line, so again, I can draw a horizontal line without picking up my pencil, so it is continuous. Another symbolic, f of x equals x to the 4th minus 2. Well, this would be nonlinear because the exponent is something other than 1. X to the 4th minus 2 forms a parabola, so this is continuous. All equations should be continuous. Next representation, again, is numerical because it's a table. Well, my y's do not change. Why my x's change by 1. So this gives me a slope of 0. That means it is constant because it is the equation y equals 4. And all constants are horizontal lines, but it was a plot of points. 1, 4, 2, 4, 3, 4, 4, 4. So this would be discrete because to plot points, I have to pick up my pencil. And last, we look at this graphical representation. And I see it is a line, so it is linear. To draw a line, I do not pick up my pencil, so it is continuous. Last, we will talk about where the function is increasing and decreasing over what intervals in interval notation. So as I start from left to right, I see that this function from left to right is decreasing to that point. So I'm going to write down decrease, increase. So it is decreasing over here from negative infinity to this point of 3. And since that is a point on the graph, the 3 will be included. Brace, but infinity cannot be included. Then my function switches and is increasing. So my function increases starting at 3 and over here to positive infinity forever and ever. Well, again, the 3 was a point, so that will be included. The infinity can never be included, so it'll be a parenthesis. All right, again, where's the function increase and decrease? I guess I did decrease first. So from left to right, this function is also falling to that point. So from negative infinity to 0, we always give our increase decreases over our domain. So that is over our x values. Infinities cannot be included. That at 0 is a point, so that is included. Then my function increases. So from 0 over here all the way to positive infinity. So 0 is a point, so it's included. Infinity can never be included. And again, on this next one, from left to right, I'm doing increase, decrease, and then increase. So from left to right, this function is falling to there. So again, from negative infinity to, let's say negative 1.5. And that is a point, so it'll be included. Then it increases to about right there. So there, from negative 1.5 to 0. Then my function decreases. So when you have more than one increase or decrease, you join it by a U for union. And that was 0 to maybe 1.9. And then my function increases. So union 1.9 to positive infinity. And last, where does it increase or decrease? As I go from left to right, this function is only going up. So there is no decrease, so that is not applicable. And make sure you write something down knowing that it is not applicable or none. If you leave it blank, that tells me you don't know. Or if you say there is not a decrease, then I know you know. It is only increasing. So from negative infinity to positive infinity, from left to right, it is completely increasing.